Hi, everyone. Hope you're doing well. Today, we're going to continue our discussion of quantum mechanics, and we're going to look at a new 1D potential. All right? The potential we're going to look at is called the finite square well. And although this problem will be a little more complicated than the ones we've treated so far, the techniques we will use will be very interesting, and it's going to set us up for more work that we're going to do in the future. So here, let's go take a look. All right. So just to recap, we started our discussion more recently. We've discussed or introduced the time-independent Schrodinger equation, and then we've looked for solutions of this equation that describes different scenarios. The first scenario we looked at was that of a free particle. For a free particle, the potential energy is independent of position, thus no forces, the particle is free, and the particle has a positive kinetic energy. Okay? And what we found there is that the wave function is in general a oscillatory function, okay? It might be a complex oscillatory function like e to the I kx, but nonetheless, that's how we can describe it. The next situation we looked at was the step potential. In the step potential, the potential energy starts at a low value, maybe 0, and then it jumps up to a high value. Oops. Maybe U0, okay? And we looked at the form of the wave that the wave function could take in this system. And you remember the way that we did this is we separated the space into two parts, the low potential part and the high potential part, solved the Schrodinger's equation in each region, and then matched up the solutions at the boundary. And we found, for example, that if the energy of the particle was less than the height of the barrier, then we'd get an oscillatory function in the left-hand side of the barrier, on the left-hand side, and a decaying exponential function in the right-hand side. So we'd have this barrier penetration. The next system was the first truly bound potential. That was the infinite well. Oh, I'm going to continue my original color scheme here. There we go. And here we got a set of quantized energy states. The energy could only take on certain values. And we found a simple formula which described those values. And we found the wave functions as well. Finally, we're going to come today to the finite well. What's the finite well? Well, it's just like the infinite well, except, well, it's finite. The height of the barrier is finite, not infinite. Like so. And our job is to find the energy states and the form of the wave function for the bound states of this potential. Okay? As I said, this problem is going to be harder than the ones that we've done already. But it's still going to be very interesting, and the techniques that we learn will be important. Okay, let's stop this introductory video, and then we'll get started on the main deal.